We're Team 115 and we're working on rapid surface testing for COVID-19. The biggest limitation on reopening the world right now is our inability to know who might be spreading COVID-19 and where. This is particularly true in shared spaces like public transport or bathrooms. But we don't have the resources to test every single person every single day. We need to be able to tell when a carrier or infectious material may have spread in an area so we can notify people who may be exposed and strategically sanitize or lock down affected areas. The presence of COVID-19 on high-touch surfaces in public places can indicate that someone has passed through with an infection, putting people at risk. Our solution uses this to identify areas that need sanitization, restriction, or lockdown. The result of which areas are contaminated with COVID-19 can be posted as public announcements or on a web platform. Here we can see how a user can easily swab a surface and test for contamination in a few easy steps.
So how does this actually work? Our solution combines existing technologies that can be put into production rapidly. Synthetic fibers are used to collect nasopharyngeal swabs for testing human samples. Wipes made of these materials will pick up the virus from a surface. Antigen testing is the quickest method available to detect the presence of viral materials on a surface. Like a pregnancy test, a small sample is introduced in a liquid solution at one end. A positive sample shows a visible color change, usually triggered by colloidal gold nanoparticles on the strip. FDA-approved tests currently show over 90% specificity towards SARS-CoV-2. However, these tests require high viral loads which are present in human samples but unlikely to be found on a surface. To increase this concentration, we introduce a sample concentrator in between. This device uses an electromagnetic field to collect magnetic beads coated with charged polymer that attract oppositely charged viral particles in solution. It has been demonstrated to collect 90% of adenovirus and influenza particles. The polymer beads are available off the shelf.
One easy way to collect samples for testing would be to swab surfaces with wipes. These wipes could be made out of dissolvable polymers such as carboxymethyl cellulose, which could dissolve in the viral elution medium. This would help extract antigens and prevent the user from further exposure to the wipe.
The sample concentrator will have a tube holder attached to a mechanical arm. The user would insert a pre-packaged tube containing viral solution medium and magnetic beads and add the used wipe. A few wipes from different surfaces can be combined in one reagent tube. They will dissolve in the reagent tube, releasing viral particles. The mechanical arm will slide down the box toward the electromagnetic field at the bottom of the enclosure. The bead virus complex forms and moves toward the bottom of the tube. The tube tilts to decant a fixed volume of the supernatant, leaving a concentrated virus solution, and moves back upward. The user then inserts a lateral flow assay strip into the reagent tube. The lateral flow assay uses capillary action to pull sample from one end of the strip to the area containing antibodies, or in our case, ligands such as human ACE2 enzyme, which is known to bind to the spike protein of the coronavirus, and visibly change color. Lateral flow assays do not show high sensitivity and may need larger viral loads for the color change to be visible. In this case, the strips can be modified by using the gold nanoparticles not only as labels but also as carriers of enzymes that generate colored products. By adding silver nitrate to the strip, a color change reaction releasing silver ions is catalyzed by the colloidal gold nanoparticles on the strip when antibodies bind the virus.
Information can be disseminated to people in area via public announcement systems like city alerts. Alerts can also be uploaded onto a website that people can check to make sure that they aren't going into potentially infectious zones. Contact tracing can be initiated wherever possible, such as in airports or classrooms. Thank you for watching.